Hi, welcome everybody. In today's video, I'm going to talk about the following course materials content in my process operation and management course module called here 2.2 briefing and exercise SOPs. That's something you're going to discover later on what SOPs stand for. So that is session 2. Actually, it was week 2, so like last week. Sorry that I had to record this video a little late because my times weren't too flexible with the video recordings as usual. So sorry for any inconvenience. And let's dive into this chapter. So I think I'm going to presentation mode switching and go to full screen. I better zoom it in so it looks like this, right? Increase the magnitudes for a better view, to be honest. So I'm going to describe the following slides. This is what SOPs stand for in abbreviation, that is, Standard Operating Procedures, or SOPs, right? You got it right? And next slide. Process Engineering Operations and Management, SOPs Principles. That's what I'm going to present to you today, so let's continue to the following slides, and please enjoy the presentation, the rest of the presentation. That's right, here's a slide. Operating procedure. Detailed set of step-by-step instructions bring about a specific procedural intent, product operators, and process equipment to be executed with thought. So the further details describe that to consider how to carry out an instruction, to read ahead, or often the next instructions may relate to the current one, and to anticipate what will or might happen to the process when you carry out an instruction. Next slide. Individual instructions are simply the following: clear, concise, instructive, little or no room for interpretation. Also, given that there may be options for an instruction, like an example says, if X then Y, else Z. As a result, options may direct you different operational steps because of this if and else condition, right? Next slide. So everyone knows this standard operating procedure Proforma using the procedure name, its number, designation, procedure intent, initial process plan status, overview, as well as final process plan status and overview. Lots of content to be filled in. Anyway, I'll go to the next slide. Here are two different contrasting starting operating conditions. You see initial process plan status and details, initial unit functional status, as well as initial process status. I'm not going to read out these description because it might have taken such a long time to read out for all of you. Sorry about that. Sorry for the inconvenience. Contrastingly here, final process plan status, details, final unit functional status, final process status. Every single variable has been determined, and you know how you carry out a particular investigation with plan status, every single detail to be inserted. Next slide. This is like simply the ones I previewed, so I'm not going to show you again. As well as this. These two are also similar to what we're going to investigate. So here, outline procedure, step A, B, C, and so on, like up to step H, but not every single blank has to be filled in because not too compulsory, as well as on the right, procedural step, instruction number like 1, 2, 3, and so on. And this page covers all the way up to number 15, and its respective written instruction here also showing blanks, but you may not need all of the following blanks as well. The next slide. This is just a brief example of process engineering operation management, how a particular operating condition has to be carried out in sequence. So procedure name going to be charge RV1 and start heating. Intent is to charge RV1 with process water to its operational level. let's say that its volume is around 360 cubic decimeters and start heating the processed water for high-grade production. Its status as an overview is here. Units DI1, PHE2 as water side, and PHE1 as the feed side have been flushed. RV1 is empty, HV1 is off, IH1 and IH2 have not been given setpoint temperatures. Also, there's no heating or recirculation of heating water. All units downstream of RV1 are not yet prepared for operation. Just brief description that you have to read them out in order and sequence before you start working other kind of stuff what you'll be investigating. Anyway, next slide. Here's the final process plant status overview example. What has been covered, right? Let's see. RV1 should be fully charged to its operational level, the same as 360 cubic decimeters. Immersion heaters IH1 and IH2 should be on. Temperature in HV1 TiO3 should be at least minimum value of 75 degrees Celsius, and the set point should be 88 degrees Celsius. There should be heating water flow through the heating coil of FiO2 at a rate of 6 to 9 liters per minute, and the overall heating water flow FiO8 should be between 15 and 80 liters per minute. AG1 should be on, and RV1 temperature as TiO1 should be increasing. RV1 set point should be 68 degrees Celsius. All units downstream of RV1 are still not yet prepared for operation. Kind of extended overview what process plant status should change from start to finish. Any values or variables might be kept constant or additionally added depending on the conditions required in the description. Anyway, next slide. So here are like some example filled in. As you can see, the red font like charged, empty. Initially is charged, less than 1, all turned off. Here's empty, no flow rate, so 0 liter per minute. Temperature range is 5 to 15 degrees Celsius, applying everything and so on. Next slide will be, oh no, this is actually the complete chemical engineering process plant that our university is investigating like from start to finish. So recent weeks have only initialized some basic fundamental operations like around, I think, heat vessel 1, I think, and RV1, like kind of an agitator with the variables that we have to investigate and do the remaining procedures in the subsequent weeks and so on. So chemical production plant, this is kind of description what entire process plant is about, like site use only, location on the Stack Hill site. Yeah. Next slide. This is it. So this is final. RV1 at first is empty, now it should be charged, change to green. IH1, IH2 all are turned on, and so are P2 and AG1. So only outer variables are shown in green and other constant variables remain in red font text. Next slide. So initial process, all are red. So final process status, you can see like FiO2 6 to 9, FiO8 is 15 to 18. Temperatures, these are increasing, and these are at least minimum degrees in Celsius required. Level alarms like NIA also change, but that's also what they might somehow ask us to change that variable and so on. Next slide. This is a different example, but I'm not going to repeat the entire description speaking to you right now. So as you part of an audience, you may wish to pause the video and preview by yourself, and I'll just keep scrolling down to the subsequent slides. So you may enjoy reading every single description here, here, and so on, like this. Here, sorry, like it just took a matter of seconds to get uploaded. And this is just additional procedure format what we are required to do this step if if we're told to do so. So here, like full start of like PPE required, that is personal protective equipment, like procedure, the following, but I'm not going to repeat that. Process note as well. Here, like very critically important as a notification. It says that currently alarm LAL05 or RV1 at low level will be tripped and RV1 will be in alarm. This alarm will have been acknowledged by the plant manager. This alarm will be reset during the procedure shown in bold. Until then, RV1 will remain in alarm. Kind of important process note you have to critically consider as well. You have to mention and compare other process operations with other procedure and so on. Here, valve status check. Here, valve status check all located near HV1. So confirm like the following: VO8 is closed and locked, VO9 is closed and locked, V61 is open and locked, and so on. I'm not going to speak everything out cause a bit waste of time, sorry. Anyway, next slide. Hello, sorry guys, like I had to resume recording this video cause there have been interruption. Like sorry for my apology and any inconvenience that you may have suffered this interruption along recording the video again. So like just the last few slides remaining, so I'm going to speak it out, so just be patient. I'm going to resume the presentation as usual. Okay, so here, unit expansion, inspection. Visually inspect the following units for damage or leaks. Check for leakage around and beneath unit of HV1 to HT1, HV1, P2, and so on. Also given the start heating system for HV1 as the following. Check level in HV1, HT1 is no more than 2 centimeters below or 4 centimeters above the yellow tape. If it is, contact the plant manager. Check temperature in HV1 on PCI computer or Mimic at location TEO3, or switch on IH1 and set the set point on PCI computer, like first select control, then heating vessel that follows, and so on. Like heating vessel control interface, you just read out these description. I'm not going to repeat because there have been too much already covered. So last few slides, just be patient here. Like the remaining procedures mentioned here, switch on IH2, start P2, PCI computer. Heating water control interface should be turned on, like select enable, button will turn yellow, or select confirm new, select mimic, and confirm that P2 is operating, where unit should be green. Check HV1 draw flow rate on local indicator as FIT08 is between 10 to 12 decimeter cube per minute, and confirm on PCI computer mimic as the point FI08. Start RV1 heating coil on PCI computer on reactor control interface, as well as check coil feed flow rate on local indicator as FITO2 is between 7 and 8 cubic decimeters per minute, and confirm on PCI mimic as the point FI2. Monitor temperature in HV1 PCI mimic as TEO3 as you continue with full startup. Also, if in full startup, go to procedure as the following shown in bold. Right. It just say end of procedure, but I don't think there has been sufficient amount of information provided to complete the entire process management procedure that I just mentioned, presented to all of you. Wait, like only 1 or 2 slides left. Here, flush DI1, PHE1, PHE2, and charge RV1. You just try to pause the video and keep reading this, all of the instructions by yourself. So I'm not going to present, but you just pause the video, take your time scanning everything out. Sorry that I lack so much speaking here. As well as here, like if in full startup, go to this procedure again. So end of procedure is over. Right? So I'll press escape button now to quit this full screen mode. Yes, it should be like this. I'll zoom it out and go back to the start where I initially showed it up. like that's the title page. Right, process operation and management of session 2 presentation is complete. So that's it all for this today's educational video that I've presented to all of you. So thank you very much for watching, and if you do enjoy, so don't forget to add a like and subscribe to my other similar educational recording videos that I've presented to all of you. Like, you can click on those links and preview them if you haven't viewed it yet, but I'll still keep recording these educational videos in the future for more. So why not stay tuned and look forward to it. End of the presentation now. I have to go. Bye for now.